Hello, today I'm going to show you a demo of our load-bearing tower placing tool version 0.9. This should be the version that will be sent to external testers to give us a feedback of if everything works and what the bugs are and how to fix them. If you are one of the testers and encounter an error, please take a screenshot and send it to my email address. So with that being said, once you start the new project, the first thing you need is to have a couple of slabs. So I'll look from the south elevation, and we're going to concentrate only on these two slabs at the moment. So I have two slabs, and the important part is they have two levels. The most important part in our tool is to place the helper families in between the levels. So that's why I created a temporary level called helper families, and I placed it in between, and then I have two other slabs that I purposely put on 2.92 meters. So the second step is to place to set the working level to be this helper family, and then you click OK and you said that you want to look from here. So once this works, you're all set to go, and you can start the tool from community tools and load bearing towers. Going quickly over the interface, from here you select the system. These two systems are not supported, so by default it should be D3. This is the number of spacing, so how many frames you want to have in one tower. You can go up to 10. This is configurable. We can increase or decrease that based on the requirements. If you have more than two, there's this checkbox where you can uncheck it, and then you can type the distance that you want between the frames. In this case, you don't have a diagonal, and in case you type a distance that we have a diagonal for example 1000, it's going to be a 1000 distance but without the diagonal. These situations are usually required in bridges, where I'll show you later how to use them and why. Otherwise, besides that, it's just you can add more frames or less frames depending on what you need, and from here you can choose the appropriate diagonal that you want. By default, they're 1.5s. From here you can set the substructure or the thing that is above the towers, which is the plywood secondary grid and primary grid. The default values are 18 millimeters, 200 for H20 beams, and 100 for the WS10. This is the orientation of the grid, which means in which direction the head to be orientated. By default is orientated parallel to the frame. From here you can choose different configurations of the frames that you want to use. T3 system has three options, and they differ in the capacity of the tower. 1.8 plus 1.2 plus 0.9 means it can use all three types of frames, and 1.2 plus 0.9 means it uses only these two, which has a higher capacity. And there is a third option, that is the first frame should be 0.9, the last frame should be 0.9, and in the middle you can put it will put all types of frames, 1.2, 1.8 and 0.9, which is the highest capacity one. So we're going to look at these cases later. And there's also two types of families that you can create. One is phase-based and the other one is adaptive. In most cases, except for bridges where you want to align a family around the curve, you should use phase-based, because adaptive families are very tricky to operate and there's always problems with them. So as with that being said, so we can place a phase-based family. We're going to choose the default value, 1.5 meter, and we click create family. We work always in the top view of 3D, because this is the way where you make sure that you see everything below you, and you place the tower like this. Once the tower is placed, you can create multiple of those. You start the tool again and create one more, and then you place it here, and then until you cancel this with escape, you can create multiple towers. What you can do is you can change the numbering. So for example, this one by default is named T0. You can change it to T1, and then you can change this one to T2, and this one to T3. Then once this is done, you are ready to form. And this would be done from the same tool. You just go to the third tab, which is generate 3D, click the button, and you have to select in the same move all three things. If you select this one and then click on that one, you might end up not selecting everything. The only way to check if everything is selected is just hover over it, and if it's showing minus, it's already in the selection. Minus, minus, minus. This one is minus. Then you press finish, and if you see the blue waiting signal, it means it works. So you can have a quick look, and there we have a tower which consists of only 2 frames, which are I think 1.2 and 1.2 or something like that. The interesting thing here is that the tower already has information about its name, so each component is being already labeled in this Docker unit assembly code. So if you want to have a quick material list that can be checked right away, you can go for the regular one, and I will show you how to create this one, and then you just duplicate it. Then you can rename it to towers mat list 1, because I already have one. Then in this one you just go to fields and scroll to this field that I just showed you, unit assembly code. I enter it, then you shift it to the top, and then you go to grouping. In the grouping you choose the same code, click header, click blank line, and then secondary option is article number, then click OK, and there you go. You have a material list broken down by tower types. Yeah, that's pretty much it. This is the basic operation, and I'll show you in the next video a little bit more advanced use of the tool.